Hello, everyone. Welcome to another problem-solving session of organic chemistry course. And today we will solve questions for the topic compounds containing a single bond to a heteroatom, part 1 and part 2. And I have prepared 15 questions for you. And let's start, my friends. As the first question, an organic compound is given to you, and the question wants you to name the given structure. And actually, the name will be according to the UPAC naming. Don't forget, we have two types of namings. The one is the UPAC naming, in other words, systematic naming, and the another one is the common names, common naming. But to put a common name to organic molecule, it must be a simple structure. It must be a carbon chain, an alkyl chain, attached to the functional group. If there are different substituents or different functional groups, we cannot put the common names. Thus, we have only the UPAC naming. And here, as you see, we have a carbon backbone here, having a halogen, the second halogen, and the third halogen. So there are three halogens, which two are identical and the one is different, attach the carbon bond. As you see, they attach the carbon backbone. Thus, it's not possible to give a common name to the given compound. Thus, we have the UPAC naming. And let me remind you to the UPAC naming. To remember the formula, I have a formula of a prefix plus parent chain plus suffix. So the suffix of an organic molecule must tell us the superior functional group in a given organic compound. And so visit my Instagram account to look at the functional groups and their priority order. I have recently posted a good illustration for you. A good table, actually, and you will find the functional groups we study, their suffix name, prefix name, and also their priority order and some basic examples. Parent chain tells us the carbon backbone having the functional group, but this definition is not enough. The parent chain actually tells us the longest carbon chain containing the superior suffix, and for the rest will be prefix. If there are substituents or any other functional groups which are not superior, different functional groups which are not superior, it will be prefix. And the prefix must tell us what are the substituents, where are they, the locants, and how many. And also, we should do some modifications in the formula. Let me choose a different color for you. Yes. If there are two suffix or for a given functional group, such as alcohols, for example, alcohols in an organic molecule, assume this is the functional group, this is the superior functional group, but there are two alcoholic groups. So the suffix must tell us how many superior groups are there in the given organic molecule. And for alcohol, for example, if it is an ol, remember the suffix is ol. And so if there are two alcoholic groups, it will be thiol in the formula. So a little modification. How many suffix? So this is similar with the prefix. If there are, assume there is an aldehyde group and both alcohol group in an organic compound, this makes the aldehyde suffix, but alcohol prefix. And if there are two alcoholic groups as a prefix, that's remember the prefix name of alcohol, its prefix name is different. It is hydroxy, which will be dihydroxy if there are two alcoholic groups as suffix. And the parent chain, we will use the UPAC multipliers. Yes, this is just a reminder for you. Let's continue on the question and look at here. Yes, in the given organic compound, as you see, it's easy to identify which it's too easy to identify the carbon backbone, the longest carbon backbone, it's 4. And remember from hydrocarbons, as a common approach, we always give the alkane name of a carbon chain, then derive it to the functional group, or the groups, the naming of organic compounds other than hydrocarbons are named as an derivative of hydrocarbons. So what is the 4? What is the 4? Yes, for the 4, if it was an alkane, it will be butane. But it's not an alkane. But we should think a bit. Look at the halogens. There are halogens. Remember the halogen naming. Remember the priority order. And the halogens are subordinate groups. Thus, they have no suffix name. They are always prefixes. This means for some functional groups, we have different approaches that we should remember. We have to remember them. And the thing is, to remember the priority order. And the halogens, thioethers, ethers, they are subordinate groups. This means they are always prefixes in the UPAC systematic naming rules. So here, thus the carbon backbone, the name will be butane. So the butane is our parent chain name and the suffix. So look at the options given. All include butane. So we cannot eliminate any of them. Let's continue. So for the numbering of carbon backbone, which is essential to give the positions of substituents, we will always look for the first carbon atom having the substituent or the functional group. It will be the lowest possible carbon number. As here it is very easy. This is the first, second, and third. So for the halogens, we know its name is bromine. For the UPAC systematic naming, the I in E will drop and will be bromo. Chlorine, chloro. Fluorine, fluoro. So we have a bromo, dibromo, and you see dibromo. So eliminate these options, my friends. Because what I said, if there were two identical substituents, there must be a prefix, or there must be a definition or a determinant to tell us how many of the premix are there in the given organic molecule. For the option B and D, there is no D, so eliminate. So for the option A and C, as the dibromo and 1 chloro, they are okay. But this time we should focus on the locants. And we have the 1, 2, dibromo, 2 chlorobutane. So the answer of this question is C, my friends. C. This is the answer. Yes, let's continue on the question 2. Now we are here. Other name of alkyl halides are the haloalkanes, a very basic definition. And also this name tells us the pattern of UPAC naming, haloalkanes. If the halo is chlorine, it will be chloroalkane, for example, chlorobutane. But don't forget, this is just a simple approach. If we have a chloropentane, we have to mention the position of chlorine, because there are many possibilities. And the alkyl halide, this pattern tells us we can also name as an alkyl group and then halide. So, for example, for the bromine again, for the bromine, drop the I and E ending and add IDE, such it will be bromide. But this is a common naming. So if we have a simple alkyl halide or haloalkane, such as here 1, 2, 3, 4 carbon backbone, and at the one end we have a chlorine. Alkyl halide pattern, which is a common naming pattern or rule, the name will be butyl, because we have a 4 alkyl group for carbon, butyl chloride. This is the alkyl halide pattern. Compare the alkyl, the butyl, halide, chloride. This is the common name. But also there is an UPAC name, which follows the haloalkane naming. And what is the UPAC name of this compound? Let me take a different color. So it will be 1-chlorobutane. So this is UPAC name of the molecule. This is the common name of the molecule. And they are same, no different. Just naming principle or naming approach is different. Yes, continue on question 3. The hydrohalogenation of alkyl halide is an example of which of the following reaction? Yes, my dear friends. Yes, I'm asking you a type of reaction. The hydrohalogenation. This D here, D, refers elimination of some group from the given organic compound. And this is common in biochemistry, such as the hydrohalogenation, dehydration, dehydrogenation. So D means here, the D and E means here, eliminate the group. And here, the elimination of halogen. So this is an elimination reaction, elimination reaction. This is the answer, my dear friends. And the other common, so elimination is a common type of reaction for alkyl halides, and another one is nucleophilic substitution, which is a fundamental type of reaction in organic chemistry where a nucleophile selectively bonds with or attacks the positive charge of an atom to replace a living group. So a nucleophile, in briefly, nucleophile attacks an electrophile. And alkyl halides or haloalkanes and alcohols and ethers can undergo that kind of reaction. Okay, continue on question 4. So what should be the correct UPAC name for the ethyl bromomethane? So don't focus on the options for now. Let's draw the molecule. And here we have a suffix methane in the name. So methane is a suffix here. So draw the methane, which means CH4. So now by writing CH4, we omit the prefixes. But here we have prefixes attached to the methane. This means attached to that carbon. And we have diethyl and one bromo. This means we have to make some change. So let's draw the molecule again. We have a carbon here, dear friends, having 4 single bonds. Which one is hydrogen, hydrogen, and hydrogen? So this is the methane. The molecule is not methane. It is the ethyl bromo. This means there are 4 single bonds, which 3 of them include different groups, and actually 2 include identical groups. So let me to erase the 3 hydrogens here, because my different, as you see, we have a 1 bromo, the bromo here, and the 2 ethyl group. The D means 2 ethyl group. So this means we have an ethyl group here. Ethyl means 2 carbon backbone and having 4 single bonds to hydrogens. And for the rest, I'm going to omit the hydrogens, you know it. And also here there are 2 ethyl groups. And yes, this is the ethyl groups. And look at that molecule. The molecule is changed to a different thing. And if you follow the carbon from the one end, as you see, actually, we can easily detect the naming is incorrect for the given compound. Because actually, there are, here as you see, 5 carbon carrying backbone having a bromine at the 3rd carbon, which makes the name, my dear friends, 3-bromopentane. This is a true option. And also, in my opinion, this is a good example to show you why naming is important. Because as a common principle, we should draw the organic molecule by checking the name. And also, inversely, if we have a given formula, we have to put the name correctly. It's a kind of picture in your identity card. So the naming and the picture must be matched. This is so important. Continue on the question 5, sorry. Okay, so in the question 5, which is the correct increasing order of boiling points? So, before reading the rest of the question, let me remind you, increasing order of boiling point or melting point is regarding to the carbon backbone, the number of carbon atoms in the backbone. If they increase, they increase. Another determinant is the functional group, the polarity, and also the atomic size of the molecule. So, continue on the question. Increasing order of boiling points of the following compounds: 1 iodobutane, 1 bromobutane, 1 chlorobutane, and dibutane. And as you see, all given compounds carrying a butane carbon backbone. So, the carbon backbone is identical. This means we cannot do any order, just checking the carbon backbone. So, how we do? So, what is the difference between the given compounds? The difference is whether they contain halogen or not, which butane doesn't contain, but the rest contain. And for the rest, they contain different type of halogens. So remember the position of that halogens in the periodic table, which fluorine at the top, the fluorine at the top, my friends. Again, I did it. The symbol of fluorine is just F, not Fl. The fluorine, then chlorine, bromine, and iodine. And from top to down, atomic size increases. That's the boiling point increases. So the option is we should check the butane, which we can easily eliminate the option B here. And after butane, there must be fluorine, but there is no given compound. We have the compound chlorine. So after butane, we should check the chlorobutane. Thus, we can eliminate that option 2. And after chlorine, bromine and iodobutane, which makes the answer, my dear friends, option. This is the correct order. Butane, its boiling point is lesser than 1 chlorobutane, it's lesser than bromobutane, and 1 iodobutane has the highest boiling point due to the iodine has the highest atomic size. So here, the parameter that we compare the molecules is the type of halogen because they have the same carbon backbone, 4 carbon. Yes. Continuing question 6, a compound is given to you and we should give the name of the following structure. And so it's UPAC naming. And as you see, there is a cyclic structure. This means we have to determine, we have to mention whether we have a carbon backbone or maybe the alkyl group as an lymphatic chain structure or cyclic structure. If there is a cyclic structure, we have an additional prefix that we have to put just in front of the parent chain or the alkyl chain. So here we have a 5 carbon, as you see, 5 carbon. It is pentane. Is it true? No, it is due to a cyclic structure, cyclopentane. What is your opinion now? It is okay? No, because we have an alcoholic group, which these are the superior group than the alkane ring. Thus, the suffix must be ol. Let me enter the E. So this suffix must be ol, cyclopentanol. But still, it's not enough. As you see, there are 2 identical groups, 2 alcoholic groups. So the suffix must include the prefix. It's the determinant that how many alcoholic groups are there. So it is cyclopentane, pentan, or pentane, thiol. So derived from the alkane naming. So, but still not enough. We have to give the position of the groups, which are the 1, 2, cyclopentane, thiol. So this is the answer. So remember, in a cyclic structure, if there are substituents or the functional groups, the 1 must be the first and the second. The carbon atom having the substituents for the 1 must be the first carbon atom and the second must be the lowest possible carbon number. So you should follow the clockwise or counterclockwise to check which one is correct. And here, if you choose this is the 1 and this is the second. And also for the given compound, if you put that 1, this will be 2. So there is no difference for the given compound. Question 7. UPAC name of the given compound. Yes, as you see in the red color, there is an oxygen atom here, which is an heteroatom, single bonded to 2 carbon backbones. 2 carbon backbones here. So this is an R, and here we have the second R, which makes an ether. So remember the UPAC naming rules or the position or the period of ether. They are always named as a prefix because it's an subordinate group. And the ether as a suffix naming, subordinate group as a suffix naming, they are named as alkoxy groups attached to a carbon chain, alkoxy. So the derives from the alkyl name. And here, as you see, to name the alkoxy naming, we have to detect which one is there are 2 R's, which is the longest carbon chain. It's easy. This R is the backbone. So this R is the alkoxy group, and there are 2 carbon, which is ethyl. But to put the alkoxy group, drop the Y and L, my dear friends, and put oxy, epoxy. And the carbon backbone here, 1, 2, 3, 4, 5, which is pentane, and the rest will be the locant of epoxy group. It is 3. 1, 2, 3. 1, 2, 3. It's not different. It's just at the middle of the carbon backbone. So the name is 3-ethoxypentane. Thus the answer is 3-ethoxypentane. I'm sorry. It's 3-ethoxy. By the way, I'm going to check before. Yes, my dear friends. Here the molecule that I draw is outside of the canva. Let me draw for you again. Okay, for the bromomethane, CH, bromine, and these are the ethyl group. This is the ethyl group. CH3, H2, 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 and H3. That's just a carbon 5 backbone having the bromine at the third carbon. Bromine, these are okay. Yes, this is the name of compound. We have 3-ethoxypentane. So this naming is ethyl pentyl ether. This is the common naming. If there was a 2 alkyl group attached with the oxygen, then we name each alkyl and then put the ether suffix. But this is just done for the simple ethers. But if we have a compound having a similar structure to that one, we have to give the UPAC name. There is only UPAC name, not the common naming. Yeah, let's continue on the 8. As you see, we have a ether again, and now this time we can put the common name, which is asking to us, and 2-ethyl, which means we have to name them as diethyl ether. This is the answer. Very basic question. So this is an ethyl alkyl. This is an ethyl alkyl. This means there are 2 identical groups. Instead of writing ethyl ether, we write as diethyl ether, which makes the answer B, my dear friends. So ether molecules at the question 9 are polar. They are polar because they have oxygen having lone pairs, but do not form hydrogen bonds with other ether molecules because there is no hydrogen atom bonded to oxygen. This is the true one. The molecules are generally too large. This is not a relevant statement. There are too many hydrogen atoms in the molecules to bond with just one oxygen atom. No. Ether molecules are so reactive that they never have an opportunity to form hydrogen bonds. This is not a statement we can accept as a true option for the given statement. There is no hydrogen bonded. So to form hydrogen bonds, they must have the hydrogen bonding patterns. These are the ones that you can check your general chemistry lectures. You can turn back to the initial topics of the course. Yes, question 10, my friends. Question 10. Common name of the given compound. And we have a nitrogen here, which makes a single bond to carbon backbone, carbon here. So this is amine. And so the suffix is amine. We have all amine. Then the common name. It is asking the common name. But for the common name, as in the ethers, we will put the alkyl names and then the amine suffix. But we have a different role in the naming of tertiary amines, especially tertiary ones. And also this is similar for the other ones. There are primary, secondary, and tertiary amines. It's about the nitrogen, or how many bonds occurred between nitrogen and carbon. If the pattern is like right here, RNH2, this is primary amine. The pattern is RNH and the second R, it is secondary amine. R and R2, this is tertiary amine. So this is the pattern we have in the given molecule. So what are the alkyls? So we have ethyl here. This is methyl. And here we have 1, 2, 3. This is propyl. Ethyl, methyl, and propyl. If there were 2 different groups or no identical groups, we have another rule. They must follow the alphabetical order. So this is the answer of question. Then the question is which we should firstly write. Which one we should write firstly. So the E comes before M, this comes before, but we have exceptions. In the tertiary amines or in the amines, the carbon chain having the longest alkyl chain must be as a suffix. So it must be with the propyl amine. So we'll eliminate this one. And the following is written as according to the alphabetical order. So ethyl, methyl, propylamine. So this is the correct option. This is the correct option for the common name. But don't forget, there is also UPAC naming. Let's give the UPAC name of the organic compound. But before, let me delete some points. Okay. Yes, we know the alkyl groups, ethyl, methyl, and propyl. So here, for the UPAC naming, we must write the propane, its alkane name, propane, and drop E and put amine. So it will be propan amine, the first position here. The rest are attached to the nitrogen of the propanamine. Sorry, not this is the first carbon here. This is the first carbon, not this one. We delete it, change the color. All right, yes. This is the carbon first having amino group. So this is why it is one propanamine. And the rest are attached to nitrogen. Thus, to give its locants, we have to use the N suffix. The N-ethyl and methyl. Look at here, I follow the alphabetic order. E comes before M. And to give the locant, I use N because they are attached to the nitrogen of the propanamine. N-ethyl, N-methyl, 1-propanamine. This is the UPAC name. This is UPAC name, my friends. And the common name is ethyl methyl propylamine. Proteins contain amines. Yes, this is true. This is what are the building blocks of proteins? The amino acids. Amino acids are the building blocks of proteins. They have a common feature, a common molecular structure. All amino acids has a carboxyl group, which makes them carboxylic acid attached to a carbon. This is the second carbon. And this carbon includes an amino group, which makes an amine. And the third sigma bond is with hydrogen, and the fourth one is to the R group. And the R groups create the diversity of amino acids. But this pattern is same. And this is the carbonyl carbon here, carbonyl group here, and the carbon attached to carbonyl carbon is called alpha carbon. Thus, the amino group is the alpha amino group because it has there's an attachment with the alpha carbon. And the alpha amino acids are the building blocks of protein. So this is true. And proteins are nitrogenous compounds, and that nitrogen comes from the amino acids, which are the building blocks of proteins. In the question 12, UPAC name of the compound. So to give the UPAC name, remember the formula. The formula also tells us what should we look for. We look for the suffix. We look for the superior group. And here, look at, there is a carbonyl group. And if we have a carbonyl group containing an NH2 attached to carbonyl carbon, it is an amide. And the parent chain 1, 2, 3, 4, 5, 6, and 7. It is heptanamide. That's the name. Option D. Very easy. Because due to nature of aldehydes, amides, and carboxylic acid, the functional group is the first carbon if there's no any other of them. Due to its nature, having the first carbon, the functional group, we can omit to write the 1-heptanamide because there's no any other possibility here. And this is same for aldehydes and carboxylic acids. Question 13, a functional group. And look at here, we have an R and SH. It's very similar to the ONH, very similar to alcohols, but instead of oxygen, this carry and sulfur make it thiol. But look at the option, there is no thiol. So if we have a compound having SH or sulfitryl or thiol group as a superior group, the suffix will be thiol. But if it's not a superior group, which makes it a prefix, the prefix name of the thiol is mercapto, and it is here, option B. And hydroxyl or hydroxy is the prefix of alcoholic group. So visit Instagram account to check the naming of functional groups, because the ones which we put them into priority order, they have suffix name and prefix name, and usually they are different. Question 14. And here you see a systematic name, or the question asks you, put the systematic name of the given compound. By the way, please be very careful during solving questions, what's asking to you, UPAC name or common name. And it's a thiol, I guess you easily detect, it's a thiol, so, and it's a superior group, so this carbon is the first carbon having the thiol, and very easy, it's the carbon backbone, which makes a propane thiol. But the thiol is at the first carbon. We have only one option here. Yes, at the 2, there is a methyl group. So this is the answer. Dimethyl, 1-propane or propane thiol. And 2,2-dimethyl, 1-ephantiol. It's not an ethane. This is true, but the locant is incorrect for the SH. It is superior, which makes the carbon, including SH, the first carbon. This is why the option D here is the correct answer. And this is incorrect naming. Assume there is an alcoholic group here, for example, which makes the SH as a prefix. For example, it will be one mercapto, blah, blah, blah. Transformation of straight hair into curly form. It is related to the conversion of thiols to thioether groups, related to elimination reactions. It's a general phenomenon of alcohols involved in the reorganization of the sulfate bridge. And yes, this is the answer. Involved in the reorganization of the sulfite bridge. Because the hair, which is rich in the protein keratin, and keratin is a rich protein of the cysteine, high cysteine residues. There are higher content of cysteine residues, and cysteine is an amino acid. It's an amino acid carrying SH, carrying thiol, and two cysteine molecules attached with the sulfate bridge. And the hydrogen is removed, and they are attached with the sulfate bridge. And the proteins of extracellular matrix are rich in sulfurous, especially cysteine amino acid. It's very important in giving shape of the protein molecules, as in the keratin, thus as in the hair. Converting it from curly to straight or straight to curly, it's a kind of reorganization of the sulfate bonds. And yes, my dear friends, this is the end. And don't hesitate to post your comments or to ask your questions. You can send me email or you can put your question on the comments section. I will be very happy to answer your questions. And please don't forget to subscribe the channel, to like the video, and click on the ring bell to get notifications. So stay safe, my friends. Stay safe. See you on the next video. Ciao.